Okay, so Daniel's going to give us a... sorry, Daniel's up next.
My name is Daniel. I work at LIFX. We make a smart Wi-Fi enabled light bulb, and that's the end of the ad. So we've been building a cloud for LIFX, which is basically a service that lets us control our light bulbs from many different locations. And LIFX users use this so that they can use their phone anywhere they are. But we also use it for several features that are part of the platform, such as scheduling and responding to other events in the cloud, like when you get an email, for example. One of the founding principles we had when we made the LIFX cloud was that we wanted deployments to be easy, we wanted them to be small, and we wanted them to be fast. And we'll go through the reasoning behind that in a sec. So by fast, we mean that the deployments should not take more than 10 minutes. The developers that we have now actually start complaining when it gets to 5 minutes, but the deployments should be small. Ideally, the only thing we should be changing is a single commit, like one single feature change. And the person doing the deployment must have the whole context of the change that's going out, so that when they're pushing it out to prod, they know everything that's going to change, and when something goes wrong, they can correlate that in their head with what they know is happening. And the other thing is we want it to be as easy as possible. We want to eliminate human involvement as much as is responsible, and we want to eliminate context switching. If you have to learn your deployment mechanism again every time you go to do a deployment, you can't concentrate on the change that you're making, and instead you have to concentrate on how to get it into production. And the other thing we wanted was to make it as simple to understand as possible, so that if you've been working, say, on another project, say you've been working on the iOS app for a while, and you come back and need to do a cloud deployment to add a new feature for the iOS app, you need to be able to pick up the deployment as fast as possible and just run with it. You shouldn't have to learn how it works again. We believe this because smaller changes mean less things are going to go wrong. It means that you can have the whole change set in your head and focused, and remember, oh, this went wrong because that change might have increased the load on our Elasticsearch servers. And when the changes are fresh in everyone's memory, then the incident response is also fresh. And it means that rolling back is also no big deal. For example, if you're pushing out a tiny change that is going to add one feature so that the next commit that we add is going to improve the performance of a particular thing, we can test that feature in isolation. We can roll it out to production and start testing it on user traffic. And also, I believe that developers should be focused on developing the app and not worrying about the infrastructure and how many servers we have and how many instances they should be running and how many CPUs they should have. It also means that projects can be really easy to learn. If you want to start developing on one of the Ruby apps at LIFX, you should just be able to pick up the Ruby app and start looking into it and then coding Ruby. You shouldn't have to go, well, how do I deploy this? How does this work? What does it run like in production? And the other thing is, I don't want anyone to be afraid to deploy. Preferably, we want anyone to just be able to go, okay, I think these changes are ready, click the button, and go to prod. If you get people afraid, then you start talking about, oh, maybe we'll do the deployment next week once we've, got someone who knows about it around. And then you end up delaying releases, and then things take longer. And then there's so many changes that you really have to think about what's going out. And every single change that you have in your staging environment that you don't have in your prod environment is something you're testing but not releasing, and it makes it a risk. And we can back this up. We have 30 separate microservices that make up the LIFX cloud at the moment. That In total, we run 88 Docker machines across 15 worker hosts. We deploy about 7 times to production every working day. Although that's an average, a lot of days we don't deploy, and sometimes we deploy way more often than that. In our 1.5 years running the LIFX cloud, so far we've only ever had 4 emergency rollbacks, where a deployment has created either a complete outage, which only happened once, or a severe outage or performance issue that had to be immediately rolled back. Everything else could be fixed by just patching the code and doing another deploy 5 minutes later. And so far our systems have been maintained by myself and a single other developer, with a few other people helping as the year went on. How did we do it? So it's kind of optional to have a microservices architecture. You could build this around a monolithic app. It's just a lot easier to make smaller changes when you're doing it on a microservices scale. You'll need a Git repo that has some ability to trigger. You could use GitHub or Bitbucket or set up your own with post-receive hooks. You'll need a build agent that lets you queue up steps and have parts of your build process and keeps track of those for you. You need a packaging format that tracks dependencies, whether that be jar files or RPMs, or in our case, it's Docker images. And Docker images doesn't necessarily track dependencies, it just packages them all up and sends them with it. And you'll also need something to manage your cluster of machines. In our case, if you watched my talk last year, you'll know that we use Mesos and Marathon for that. So what's the step in a deployment? So it starts by writing some code that you want to get into production, and then pushing that to the Git repo, obviously. And then the steps in here are bold, are the ones that we think are automated, and the other ones aren't. Obviously, well, we can't yet automate writing code soon. So then step 3, we build the application. A lot of applications don't actually have a build step if they're an interpreted language, but they sort of do because, say, if you're building a Ruby app, you might need to use Bundler to collect all its dependencies because the application isn't going to run without those. And then there's the automated tests, which in this case is at the moment just unit tests. And then we package it up, including all its dependencies together into a Docker image or whatever packaging format you like. And we deploy to staging. Now, I haven't gone over end-to-end tests because what we actually do is run continuous end-to-end tests against staging and production. And we actually hook those up to our alerting. So then you'll test it in staging, which is usually either a manual test or sometimes it's kind of hard to do a manual test, so you'll just write an automated test. And single-click approve to prod. Obviously, you want a person doing that, unless you're really confident in your testing. And then the deployment to production, which is going to look similar to staging. So building the application. When your source code repo gets a new push, it should trigger the application to be built. As I said, not all applications need to be built. But all will have sort of a step in that area, really. We have a standard across all of our repos that we put a build.sh script in. The main reason for that was we wanted to be consistent. Everything has a shell of some sort. Realistically, if all your projects are C or Go or something, you could use a makefile. We could have used a makefile instead of bash. But it's really up to you how you build your own application. Just try to be consistent across all your repos. Next step is automated tests around. We actually do this at the end of our build because there's no point pushing a build anywhere further if you've tested it and it failed. Consistency is key again. Try to keep as much the same as your other projects. That doesn't mean you shouldn't have projects that are different. Obviously, testing a Ruby application is going to be different to a Go application. We don't do end-to-end testing here, and I wouldn't suggest that you do it because you don't know which versions that you need to be testing against while you're still building the application. There's no sort of, unless you have sort of environmental awareness at this stage, you can't really test the integration between this and another application. And as I said earlier, we do our end-to-end testing continually as a check that just constantly runs against our staging and prod environments. Then you package the application up. We build Docker containers with a Docker file, although we do have some steps around Docker that do things like tagging and squashing certain layers together. And then you push it to, in our case, we push to an internal Docker repository on Google Compute. But obviously, if you're using an RPM, you'll push it out to your repositories and not run create repo, and various other things. Obviously, yeah, you can package it up any way you like. And you can choose to have per app repositories with just, different versions of your application per repo, or you can have a repository containing all your RPMs. It depends whether you want to save time or how you want to manage that build process. Deploying to staging. Because we use Apache Mesos and Marathon, our deploy process is basically just a curl command that, a sed command that adds some variables to a JSON file and then pushes it to Marathon using curl. These two tools make it really easy to deploy, and I'd stress that everyone should be having a look at them. You can use these with or without Docker. The only thing is if you're using it without Docker, you have to have a way to get the code that you're running onto the machine first. Whereas if you're using Docker, Marathon will actually pull the Docker machine for you, and everything's all good. And then the single-click approval. Now, this is a manual stage in our case, but once you've deployed to staging and it's been tested, someone needs to approve it to go to prod. Generally, you'll have some kind of trigger in your build system, but not all of them have that. We're lucky our build system does. But the one thing you want to be careful about is you want to make sure that you audit whoever clicks this button. Because it doesn't matter whose commit's going out, it matters who's actually calling themselves responsible. And this way, if something goes wrong, everybody can look and see the last deployment, say in your IRC channel, and see the last deployment that happened. And then if something has gone wrong immediately after, everyone knows to ask that person any questions that they might have. And then deploy to prod. In theory, your deployment to prod should be exactly the same as your deployment to staging. If you're using Mesos and Marathon, they probably look very, very similar. And just remember, though, you shouldn't have a different process, because if you have different processes in production and staging, then when you're deploying to staging, you're not really testing what it's going to be like deployed to prod. And that's how we did it. So LIFX is hiring a cloud engineer and a firmware engineer. Cloud engineer will be working on my team with the LIFX cloud, and a firmware engineer obviously writing firmware and C. If you're interested in these, email me at daniel.hall@lifx.co, or come talk to me at LCA sometime this week. These slides will be available at that URL, and I'll post that on my Twitter after this. So, any questions? Yes.
You were saying that the first point of end-to-end testing is in a staging environment.
Yes.
The deployment that breaks that end-to-end testing, does it automatically roll back, or do you just do break fix in that environment?
We don't automatically roll it back because it might be interesting for someone to debug. So if something's gone wrong in our staging environment, we just leave it in that state and obviously write it in all our communication channels, and then have someone come along and, because if they've just done a deployment, 2 minutes ago, so they'll probably want to know what happened.
But doesn't it give you a situation where staging might start to vary away from prod significantly?
Yeah, so the idea is that, the question was, because if a deployment to staging breaks, won't that mean that staging will start to vary away from production? Yes, but that person is then responsible for resolving it, and they'll either roll it back or fix their change before they push it out to prod. In our case, most of the time, if it's a break to staging, it'll end up either getting fixed or rolled back within a couple of minutes. We had another... Oh, by the way, I'll give LIFX bulbs out too. I've got 4 to give away, so the first 4 questions. Yes?
If you have, say, you work in a company with 100 developers and
Yeah.
changes are constant,
Yeah.
what would you recommend to do to, say, have different staging environments so they can be testing different things at the same time, or to, say, bundle, 3, 4, 5 features and make a single deployment with 5 features, or 5 deployments with a feature of each?
Yeah, so the question was, if there's hardware deployments happening in your company, do you bundle all your changes into a large deployment, or do you do them separately, one change at a time? I can't comment on the firmware team. I know it's a lot harder for firmware because they have to test all their changes together before they push out a package. And if they break the update mechanism, for example, in the push out, then they'll break a whole lot of bulbs. But on the cloud side, we have a strict contract with firmware. We know exactly how the firmware works, and that doesn't change without lots of prior notice. So we basically push out changes the minute they're done on the cloud side. And when we test it in our staging environment, it tests against all the firmware versions that we have out in the wild in our staging environment as well.
Next was just try that guy.
Which one?
Oh, sorry, I thought you had
No? All right, next. Yep.
So the other question is scaling, right? So
Yes.
this works in a small team, you've got less than 10 changes a day. On average, maybe a busy day you do 50 or 100 or 200, but it's not large numbers of people, large amounts of developers. What are your thoughts on scale up? When you start having 20, 100 developers, you've got commits coming in at every minute.
Yep. So the question is, how would you scale this out? And what I would say is, at the moment, yeah, that isn't really a problem because we only have basically 2 people pushing changes at any time, and we only have, say, 88 Docker machines running. I would say in the future, as we need to scale more, we'd basically start enforcing the same as we do to our hardware, strict contracts about behavior between our different services. And then that way, when you're deploying, you should be able to deploy multiple different versions of things at the same time, and they should react the same, provided they meet the contracts that they've accepted. And then you have to be careful about managing the change around those contracts. Okay. Yes. Yes, so that isn't really a question about my talk, but the question was, how can I use the LIFX bulbs without the cloud? The LIFX bulb actually hops on your Wi-Fi network. You can talk to it directly if you don't want to talk to the cloud. And if you don't want to talk to the cloud, you just bar it from the internet or just don't claim it in the application. Cool.
Up here on your left.
Yeah.
So, obviously, like the approval button being manually processed isn't necessarily where you want to be. Where you want to be would be like a screen where everything's totally automated, right? You push and it will do all the test passes and you go straight to prod.
Yeah.
What would you say, like, would be required for you to be comfortable for removing that button, and if the test passes, you go to prod?
So the question was, what would I say we'd need in order to be able to remove the single click button and make commits go straight to prod, provided they pass all tests? A test suite that covers absolutely everything, which is really hard. I guess the advantage of a manual user coming in at that point is because they know what change they made, they kind of know what areas to test, and although they should be putting it into their automated test, there is a fair amount of intuition around there that a machine can't exactly get. But you know, I'd be happy seeing it one day go completely automated, and then we deal with exceptions as they happen. Is there anyone else? No? Yep.
Couple more questions.
Yeah. So sort of related to that, how often are you hitting problems in staging and having to roll stuff back?
Yeah.
Is that reducing? Like, has it had an effect on how you code? So you're seeing less of those issues, so you're getting close to that point where you won't have to do that. So you understand what I'm getting at?
So I think the question was,
Answer the question you think it is.
are we are we seeing less issues in our staging environment as time goes on that don't make it to the production environment?
Sorry, you're seeing less issues that you're having to roll back.
Oh, okay. Are we seeing less issues that we have to roll back in our staging environment? Yeah, our developers, my developer, they're very connected to these changes because they just wrote it and they're just pushing the code out now. The desire to fix it is a lot stronger than the desire to just revert it. So generally, we see the changes, we see a few more commits come in and then that goes again.
So I guess it's semi-related to that then.
Yeah.
Are they changing the way they code so those issues are happening less, or is it... So you're seeing less issues as opposed to them following it through, then going back, then going, oh, so sort of going back and forth.
Do you have a testing environment prior?
Sorry.
Do you have a testing environment prior to staging? Is there a capability for you to test it before it hits staging?
So the question is there a capability to test things before staging? Yeah, every microservice can be tested in isolation, as long as there's either stubs or replacements for their dependencies. And in almost all cases we have that. It's kind of hard to test against a real hardware bulb a lot of the times in your development environment. That's kind of what staging's for. But yeah, and we do have the capability to spin up more environments apart from staging. So someone could create a complete replica of the staging environment just for themselves and test this if they thought that the change was scary enough that they needed that. Cool. So the first 4 people that ask questions, just come to me on the side there and I'll hand out LIFX bulbs. Thank you.